Okay, data. The first thing we'll look at is box and whisker plots. So you said you understand that. All a box and whisker plot is something that looks like that. That's its whisker, and that's the box itself. This is called the maximum data set value that you have, and it is the minimum data set value that you have. This is called the median, which you can also see it as Q2. This is called Q3. Alright, and this is Q1. Okay, so that's the 25th percentile, and that's the 75th percentile. And all that means is 75% of the scores are here, for example, and 25% of the scores are here. Right, and that's the maximum, that's the minimum, and that's the halfway line. Then you will learn interquartile range. Where am I? Interquartile range. Have you heard of that before? Okay, interquartile range is nice and easy. You know what range is?
Yeah.
Right? Range is what? Highest minus lowest. Range is just technically your highest number minus your lowest number. That's it. Alright, range is just your highest minus lowest. So it would be your maximum, in other words, minus your minimum.
Yeah.
So max, take away min, would give you your range. But I want interquartile range. That's not too hard. So your interquartile range is actually just this part here. Cool? So that's your interquartile range. How would you do that? Q3, take away Q1. So this part here, take away this part here, would give you whatever's inside in between. And that's the interquartile range. But how to work it out is a little bit trickier.
Yeah.
Okay, so let's go to the relevant page now, 67. Let's get a data set out, and we'll be able to have a look at this. Any questions right now? So imagine we had this nice and easy set, 6, 8, 9, 10, 12, 15. Okay, let's find Q1, Q2, and Q3. Alright, Q1, Q2, Q3. The easy one is the Q2. Well, that's just your median, right? So you would just add up all these scores. You would count the number of scores, 1, 2, 3, 4, 5, 6. So since there's 6 numbers, you got to go divide by 2, which is 3. But then, as you can see, it's in between here somewhere, so it's 9.5. All the way you've usually done it will also work, of course. And then, oh, whoops, it's meant to be these two, 9 and 10, so it's 9.5. Now, your Q1 is not that hard. All it is once you've got your median, you try to find you break it up into 2 groups. Break it up into 2 groups. That's group 1, and that's group 2. You find the median of that group.
Okay.
So Q1 is 8, and Q3 is 12. And that's how you actually make your box and whisker plot. Because now you've got your minimum is 6, you've got your maximum being 15, you've got your Q1 is 8, you've got your Q2 is 9.5, you've got Q3 is 12. So you should be able to pretty much draw this thing out.
Yes.
Okay, so if I was to draw it quickly on the side here, you would draw something like this. That's 6, that's 15. You've got a Q1 at 8. You've got Q2 at 9.5. And then you got that at 12. Something like that. Obviously with this line not in there. That's it. Cool. So yes, this is meant to be exactly a little bit closer here. It's not meant to be halfway. Okay, because that's only 1.5 away, but that's around 2.5 away. So that's why I've drawn a little bit more to the left. Easy stuff so far. No main problems. Interquartile range, Q3 take away Q1. So it pretty much gives you the 50%, right in between them, pretty much. Okay. What if I gave you now? All good? Okay, what if I gave you this number? I gave you a cumulative frequency histogram, for example. What would you do in that case? Well, let's have a look. So you know you got 14 data sets because it's a cumulative frequency histogram. So it's going to keep getting bigger. Now you want to divide it by 2 to find where your median point is, right? Because I said you're going to first work out your median point. So it's around 7. Oops, around 7, somewhere there. So 7 is going to be inside this region, according to my diagram, right? So that's your Q2. You want to find Q1, so you want to go and break pretty much this up. Now it's already broken in half because that's easy. So now you know it's either this half and this half. So you want to find the median of this part here, and you want to find the median of this part here. Well, the median of these 3 sets, 1, 2, 3, must be this one here.
Yeah.
Cool. And this is a little bit trickier. Let me see. 1, 2, 3, and I just did it like that. Yep. Since I've got 7 here, and then this is 4, right? And imagine the score was, let's just say this was a score 1, 2, 3, 4, and 5. I'll do it mathematically just to show you. So there's 4 1s, but then because that's number 7, so there's 3 2s. Can you see that?
Yeah.
So there's 4 1s, so that should be 1, 1, 1, 1, and then there's 3 2s. So 2, 2, 2. That gives you 7, right? And now I can go cancel it out, and you can see it should be 1.
Yeah.
Or that's the other way you got to tell. When you realize there's obviously 7 numbers, you divide it by 2. 7 divided by 2 is 3.5. But then you round it up, you go to 4. So it's the 4th number.
Yeah.
So then the 4th number must be the number 1. So your Q1 is equal to 4. Is equal to 1, a score, right? We're looking at scores, right? Q1 is 1, score. Not frequency, these are frequencies. These are frequencies, these are my scores, right? Q1 must be, the first quarter is 1, not 4. I wrote 4 by accident. You get that?
Yeah.
Scores, just like here. I wrote 8, 9.5, and 12. I didn't write how many times I saw 6. It's not your frequency, that's your frequency. These are your actual scores. So if I want to list this out, I would write 1, 1, 1, 1, 1, 1, and then it's gone up to 8, for example. So I would write 4 2s, and then it's gone up to 10. So I would write 2 3s.
Okay.
Do you understand how cumulative frequency works? No. I want to hear a no. It's better. Okay. So cumulative frequency. Do you understand the difference between frequency histogram compared to a cumulative frequency histogram? Because they're 2 different things. There we go. All right. So frequency histogram compared to a cumulative frequency histogram. Okay, a frequency histogram. Well, remember you have you got a set of scores. Let's just say 1, 2, 4, 5, 5, 6, 6, 6, and then let's just say 7. Right? So you went and found obviously a little scores and table, scores and frequency table. So that's your X, that's your F, that's your FX.
Yep.
Do you remember that table?
Yep.
And from X you would have written 1, 2, 4, 5, 6, and 7. But your frequencies could have been different. Your frequency is now 1, your frequency is 1, 1, 1, 2, 3, 1.
Okay.
You get that?
Yeah.
And when you're doing your FX, it's more for your average. So we're not going to look at that yet. So then when I went and sketched it up here, obviously this was my X, which is my score, and that's my F, which is my frequency. So I have the number 1, 2, 3, 4, 5, 6, 7 here. And then I've got, pretty much because my highest value is 3, I'm going to have the number 1 there, number 2 there, and number 3 there, right? So how many times do I see 1? 1 time. So it's going to be like this. How many times do I see 2? 1 time. So it's going to be like that. 3. Oh, I have no 3. So it's going to be 0, so you don't write nothing.
Okay.
Right? 4.
This one.
5 is twice. 6 is twice. And then 7 is once. So I get something like that. That's my frequency histogram. But my cumulative frequency histogram is a little bit different. You're going to create another table. That's called the CF. Cumulative in English just means add on top. Add on top. So add on top of frequency. Okay, so cumulative frequency, the frequency is 1 here, and you're going to keep adding on top. So the next one should be 2, 3, 5, 8, 9. Which means at the end of the day, your last number here should be the number of frequencies as well.
Yeah.
Cool. And as you can see, cumulative frequency can never be going down. You see how this one was going down and so forth?
Yeah.
Cumulative frequency cannot go down. So if I was to sketch this one here, I have X here, I have CF here. Now, again, 1, 2, 3, 4, 5, 6, 7. My highest number is 9, so we're going to go, let's go 2, 4, 6, 8, and then 10. That's meant to be 6 there. Cool.
Yeah.
That's it. And then number 1, obviously, is somewhere here. Number 2 is at 2 now. Number 3 is at 3 now. Sorry, no, number 3 is not there, so it's meant to be a straight line.
Yeah.
My bad. I don't know why I just didn't put a 3 there. Number 3 is 3. Number 4 is 3. No, number 4 is 3 now.
So if the number isn't there, you just keep it
Straight.
Okay.
Yeah. For cumulative frequency, because it can never be going down.
Okay.
Yeah.
Because you're adding the numbers. But you're pretty much adding the numbers.
What do you mean?
Like in the CF column.
Yeah.
Pretty much adding.
Yep. But it's keeping a constant, so
Yeah.
you're not really doing anything to it. That means there was nothing. There was no 3s.
Okay.
Cumulative frequency, if you're not going up in any way,
It's the same.
well, that means there was no score.
Okay.
Wait, do you get it though?
Yeah.
Because cumulative frequency must go up. So here, as you can see, where am I? Here, my numbers are always increasing up. So as I'm going to the next one, even if there's one of them, it's still going to go up.
Yeah.
Because it's saying at least there's one of them. But if there isn't, that means, for in this case, there isn't, so that it's trying to say that there is no 3s.
Okay.
But for this one, you're going to completely leave it. There's nothing. You don't draw something. It's a gap.
Yeah.
Right? Because there's no frequency for it. But cumulative frequency, there is. It's still 0, and that's how it's kind of represented. It's kind of tricky. But anyways, 5, it goes up to 5, so now you're somewhere here. 6, you're going up to 8, somewhere here. And then 7, you're going up to 9, somewhere there. That's it. And then when I draw my ogive, which is the whole line, it's called the polygon in other words as well. You might hit a cumulative frequency. Obviously, you start off at the ends for this one. Okay, so again, there's a difference between the way you draw your polygons as well. All right, the polygons here must be at the end points. The polygons here are at the middle. And they start off at the origin and end there. So that's the big difference between the two. So that starts off there. Right, really bad, but this one, at the end points, not halfway. and does not go down and does not start at the 0. Okay, I've started it towards the end of this one, so it looks like that, and I started it here.
Yeah.
I did not start at the 0. But that, you guys start at the 0 and you go halfway. So that's the biggest difference between the two as well. Yes, you will lose a mark in your temp for stuff like that. Okay. Easy? Okay, anything else? No. Now I was talking about interquartile range. So interquartile range is Q3 take away Q1, as we said. So well, we can work out Q2 really easily. I mean, you can work out Q3, Q1 if I've given all this. But I'm not going to use this. We're going to try to prove it later on. Okay, we're going to try to use it from our table. So Q2, well, you go and have a look. This was number 9, right? It was the 9th score. Bad drawing. That was 9. Let's do each one in red. So that was 8. That's fine. That was meant to be 5. And that's 3. And then otherwise we're good. Okay. Okay. So to find my median, I'll go 9 divided by 2, which gives me 4.5. So therefore it's the 5th number, right? So the 5th number would, according to cumulative frequency, you can just go have a look at the 5th number here, right? Because that would be the 5th number. Think about the frequencies. So you're adding them up, so it's telling you it's the 5th number. So you go across, and when you go across, you can get to this score here, which I think we did as the number 5. Okay, as we can see there, that's 5. So my Q2 is in there. Make sense?
Yeah.
If you want to check it, there it is. Or let's there it is. Cancel 1, 2, 3. 1, 2, 3. Cancel that one out. Cancel that one out. Can you see you got the 5 there? Or you can do it via this one. 9 divided by 2 is 4.5. It's the 5th number. The 5th number is there. You go across. It's the number 5. So all 3 ways would work. Cool.
Yeah.
Now to do Q3 and Q1, you got to try to find. You got to try to break up into 2 groups. So now that you've found your Q2, you know you're trying to find before 5. So the median before 5, and you're trying to find the median after 5, between 5 and 9, pretty much. Okay, so 5 and 9, how many numbers are they going to be? So it's going to be the second number in that group. Do you get me? So the second number in that group, well, 5, no, you got it. 5 to 8, there's 3 numbers, isn't there? 8 to 9, there's only 1 number, which is the number 7. Yeah, see, look, 3 numbers, 1, 2, 3. But this tells us between 5 to 8, there's 3 numbers. There's 3 numbers of 6.
Yeah.
So that means your Q3 must be 6. Again, we can check it here, knowing that this is out that. So there's my group 1, and there's my group 2. Cancel that out, you get 6 and 6, divided by 2, you still got 6.
Yeah.
Cool? Alright, Q1. Now, you're up to 5. How many numbers are there going to be up to 5 then? How many numbers are before 5? 5 this time, not 4. Remember, from 5 to 9, how many numbers are there? 4, because 5, 6, 7, 8, 9. But then from here, there's 1, 2, 3, 4, 5. So there's 5 numbers. What's half of 5 this time? 2.5. 2.5. So right, so and then we go to the third number. So 2.5, you round it up, goes to 3. So we want the third number. The third number is there. The third number must be the number 4. Cool. And then again, we can check it out. But sorry, the third number must be the number 4. So then we can check it out from this. Which means I've done it wrong. The answer should be 3. Third number should be 3. No, the third number should be 4. Yeah, it's interesting. Oh no, it is. Wait, 6, 8, 2 plus 4 is 6. 6 divided by 2 is 3. How come they're contradictory? Have I done something wrong? 9. It shouldn't be 4. I know it should be 3 because I've made the data set here. Unless my diagram's wrong. At 1, at 2, at 3. Should 3 exist at 4? So it's a third number because we're going to break that up. There it is. We realized, is it the third? It's between the second and the fourth. Yeah, that's how I should have done it. Alright. I picked a hard one for myself, but oh well. When I did 5 divided by 2, which is 2.5, right? You don't, because there's actually, think about 5. There's going to actually be, when you cross them out, you're going to have a middle number. With even number of scores like the 4, remember how we had 4 before? You're not going to have even numbers, right? When you cross them out, you're going to have whatever's in the middle. So that's actually okay. But this one, because I skipped the number 3 here, when you're doing 5 divided by 2, which is 2.5, it's meant to be what's between the 2 and the 4. So what's the 2.5 number? What's the 2.5th number, pretty much? So what's the 2.5 number? It's between the second and the fourth number. Second and the third number, sorry. So what number is between the second and the third? So what number is between 2 and 4? Yeah, 3.
So it would be 3?
It would be 3, yeah. That's how you meant to do it. So because I skipped it, which is my bad. But
if it's in a system, it does skip a number, can you still say it's 3?
yeah, you have to say it's 3.
Okay.
That is right. It has to be 3. So we'll do a couple now. We'll do a couple more now. And we'll realize it a little bit more in detail. But that's it. That's pretty much the interquartile range that I'm more interested in.